So Piaget concludes and says, if all knowledge is always in a state of development and consists in proceeding from one state to a more complete and efficient one, evidently it is a question of knowing this development and analyzing it with the greatest possible accuracy. Okay, so Piaget figures you're a information foraging machine, so to speak, and the process that you engage in while you're foraging for information and then figuring out what to do with it is typical to human beings, and there's some constancy of structure across human beings. Okay, so that's the first idea. It isn't that we all do it in a different way, even though there's individual variation, obviously. The other sort of fundamental postulate of constructivism, especially the Piagetian version of constructivism, is that you sort of build yourself from the bottom up, starting with your body. So this is one of the things about Piaget's theory that's unbelievably sophisticated, I think. So when people were first developing models of artificial intelligence, they thought they'd be able to develop machines that sort of modeled the world, and then figured out how to act in the world, sort of abstractly, and then would, after they figured out how to act in the world, would then act in the world. But that proved to be impossible, as you can tell, because we don't have, ambulatory robots that could like bus tables at a restaurant, which turns out to be, by the way, a very complex job. Fast mathematical operations, computer can handle that easily, but bussing a table, it's like no computer's smart enough to do that. So that's pretty peculiar. But it turned out after like 40 years of investigation that you couldn't build computers that would operate as independent robots by teaching them to model the world, and then by having them model the potential action that they were going to undertake, and then by implementing it. That did not work, partly because modeling the world is way more complicated than anybody ever suspected. It's like infinitely more complicated. And so some robotics engineers, such as Rodney Brooks, who worked at MIT, started building robots from the bottom up. He made these little mindless robots that really didn't even have a central processor that were action-oriented. So like the first things he built were these little insect-like things that could skitter away from light. That's all they could do. You turn on a light, poof, they'd go find some dark. And it's as if, so imagine the world to that robot was a binary place. It was either a light place or a dark place. And then you might say, well, what did light or dark mean to this little robot? And then you have to ask yourself, well, what does meaning mean? And that's a very good question. It's one that Piaget answers. Meaning means, to that little robot, move to a different place. So light to that robot meant move to a different place. So what the robot, in a sense, was doing was transforming one form of information, light versus dark, into another form, which was skitter away. And so I love that, because it's not easy to understand what meaning means until you relate it to the body. And so Piaget's fundamental proposition is that the elements of your understanding are not perceptual abstractions. In fact, there's even elements of understanding that underlie your perceptual abstractions that are more fundamental. And what those are, essentially, are sensory motor skills, things you do with your body. It's a lovely idea. It's extremely profound. And I think it's absolutely correct. It does wreak havoc with the idea of disembodied intelligence, however, because for Piaget, and also for Rodney Brooks, who is responsible, by the way, just so you know, some of you have seen Big Dog. Have you seen Big Dog? Look up DARPA, D-A-R-P-A. How many of you have seen Big Dog? How many of you are terrified by Big Dog? Yes. Big Dog is this robot that's being developed by the US Army that is about this big, and it's four-legged, it's got a head, and it can run like faster than you, and it can run in snow, and it can run on ice, and it can run up hills, and if you kick it, it balances and stands back up, and hypothetically it's going to be used to transport like the heavy things that soldiers have to carry. But don't believe that, that's a stupid idea. Once these things can ambulate by themselves, and they can already follow each other because now they have visual systems, arming them is going to be a very simple matter. And so the probability that we'll have unbelievably super fast robots that can shoot you in 10 years is, like, to me, as far as I can tell from the development, is absolutely certain. I have a friend who's a computer engineer, and he's a really good one, and he said, you know how in science fiction movies sometimes when those robots shoot at you they miss? He said, when the robots shoot at you, not only will they shoot at where you are, but they'll shoot at the 6 places that they calculate you're most likely to dart to, and they will never miss. So that's a lovely thing to think about. So hopefully that won't come to pass, but it probably will. So here's the sort of thing that Piaget was interested in. These are very fundamental questions. And he was a very deep intellect, so he tried to go right to the bottom of the structures of knowledge to find out what was down there. Upon what does an individual base his judgments? That's a good one. How do you know whether you do A or B, or what the difference is between right and wrong? How is that instantiated in your being? What are your norms? How is it that those norms are validated? What's the interest of such norms for the philosophy of science in general? Which is a question like, well, there's a consensual reality that we all share to some degree, which is why we can communicate, but there's not a one-to-one relationship between that consensual reality and the categories of science. So Piaget was interested in the similarities between our consensual viewpoint and the scientific viewpoint, and the differences. So for example, people used to hypothetically assume that the world was flat. And you could say, well, the reason they assumed that was because it looks flat when you look at it. So it was an empirical observation. But obviously there were other observations that we managed to produce that indicated that the world wasn't flat. And then our scientific conceptions and our interpersonal consensual norms became divorced from one another. And that's become a really serious problem, say with branches of science like quantum mechanics, which, you know, they're absolutely, completely incomprehensible from a pragmatic perspective, even to those who formulate them mathematically. And Piaget would say the reason for that is that, well, when we interact with objects at the phenomenological level, which is the level that we can most easily perceive, they act Newtonian, you know, so, can I take your pen? So, you know, you can sort of predict what this pen will do because it acts like other objects of about its size and shape with mass. And so your understanding of this is actually based upon your knowledge of what will happen if you manipulate this thing with your body. You know, it's solid. You'd be very surprised if you could like put your fingers through this pen. You'd be surprised if it broke because you expect a certain hardness. You do expect it to write, although pens often don't. You expect it to be pointy. You know that you can take it apart into many objects, even though, like you could ask, how many objects is this? Well, it's one pen, right? But you could take it apart, you know, and now it's 2 objects, and then you can see that there's other objects in here, and sometimes you can put it back together and it'll still work. And so, Piaget's point is that what we regard as understanding, to say that you understand something, is to indicate that you can predict what is going to occur if you interact with that object with your body. Okay, and that gives you your intuitive understanding of things. And so, because this is material, you already know something about other things that are material, right? And you can transfer it from place to place. And that's again an embodied knowledge, because material things are those things through which you cannot put your hand, right? You get some weird things like smoke or clouds, and it's like, well, what are they? Are they objects? Is a cloud an object? Well, no, not really, because an object is one of these things that you can sort of manipulate as a unit. Now, the categories of quantum mechanics, of course, which deal with these incredibly tiny things that are really not particles and are really not waves, they're incomprehensible to us because we never manipulate anything at that scale. And so because we can't play with it, we have no real way of understanding it, because our understanding is based on the mapping of objects onto our body. So any object we can't map onto our body is therefore fundamentally incomprehensible. It's a very cool theory, you know, and a very body-centric theory. So how does the fact that children think differently than we do affect our presumption of fact itself? That's a very interesting question too. It's like, so you've got 3-year-olds, and of course they're pretty clueless about the world, but and you know more, but there's the 3-year-old is alive and everything and functioning. And so then you have to ask yourself, well, if their conception of the world is qualitatively different than your conception, how is it that you can both survive in the same world? And what does that mean about what knowledge means and about the limits of knowledge? I mean, I could say the same thing about you that you might say about a 3-year-old, which is, well, if I took you from this place and dropped you in the jungle, you know, soon you'd be dead. First you'd be miserable, then you'd be dead. And so that's sort of like the 3-year-old's state of being if you were supposed to take care of them and you disappeared. So obviously even your knowledge of the world is limited by what? It's limited in its necessary generality by the context. But that also has something interesting to say about the validity of your knowledge itself. It's sort of context dependent. So, okay, so that's the sort of thing that Piaget was interested in. Here's some other ones. What do you mean by number? So that's an interesting one. So you know how they say you can't compare apples and oranges? Well, you can. So if I said, well, what's 2 oranges plus 2 apples? 4 fruits. Who said that? Yeah, very good. So the way you solved that was by generalizing up a level, right? So if I said, what's 2 desks plus 2 rocks? What would you say? Yes, man. You're very good at this particular stuff. That's an IQ. Those are IQ questions, by the way. So if you didn't get them now, you could feel disappointed, depressed. So if you got them, well, then you can pat yourself on the back. So that's good, yeah. So number is a funny thing because, well, as I pointed out with the pen, well, 1 can become many very rapidly, and many can become 1. And well, the whole idea of number is extremely difficult to understand, you know. Like, what is it in common between singular entities that allows you to represent all of them with 1? Well, animals don't do that. They can in a sense. They can sort of intuit 3 or 4, which is about all we can intuit too. But once we get the nomenclature done properly, man, we can use numbers like crazy. And then they enable us to manipulate reality like mad. So whatever it is we're extracting from the commonality between objects seems to be something that gives us incredible power. So that's a problem. What do you mean by space? Since we know, for example, from Einstein's work that, you know, space is not an absolute in any sense. It is at the speeds we move. So what do you mean by time and speed? When is an object permanent and when isn't it? And when do you learn that? What does it mean that an object is the same across time? That's a good one. So, you know, I don't know if there's a single molecule in your body that was there, you know, 5 months ago, 6 months ago. There's some, I don't remember what the turnover duration is, but it's fairly quick. So it's weird, eh? Because there you are and you were there 2 years ago, but none of your constituent elements are the same. So how is it that you can be the same? Now, the physicist Schrödinger, of the Schrödinger's cat fame, solved that by claiming that you were a dissipative structure. It's a very interesting way. That's what he thought life was, dissipative structures. A dissipative structure is the same as a, you know, when you pull up the you call that at the bottom of the sink? Stopper. I think so, stopper. If your sink is full of water and you pull up the stopper, you know you get a whirlpool, right? And all the water spins as it goes down the drain hole. And you'll notice that whirlpool looks sort of the same across time, even though obviously the water molecules that make it up are different. He called that a dissipative structure. It was a pattern that maintained itself in spite of the movement of matter through it. And that's what you are, by the way. So it requires energy to keep a dissipative structure intact. But you take in energy, so thanks to the sun. What do you mean by chance? Why do you have moral concerns? And what does it mean that you have moral concerns? That you have ideas about how people should behave and how they shouldn't behave? And you have a very deep understanding of that, and it's characteristic of all human beings and many, many animals. So where does that come from, and is it a valid form of knowledge? What are children doing when they're playing? What are people doing when they're dreaming? And what's the significance of the fact that you can imitate other people? Now, I'll start with the last one briefly. You know, you might think that one of the things that really distinguishes us from other creatures, animals, is the fact that we have a thumb. And that's a big one. We've got very good functional thumbs, and hooray for that. And we stand up on 2 feet, so we get a chance to use our thumbs and hands to carry things around and to break things and to take them apart and to swing sticks and so on. But there are other animals who can do that to a limited degree. And then there's our ability to talk. That's a major one. But one of the other things that really differentiates people from other animals is, you know, you hear monkey see, monkey do, right? Well, that's wrong. Monkey see, that's the end of that. Monkeys really can't imitate one another, and they certainly can't imitate any even randomly generated novel behavior that another monkey produces. Think about it this way. You know, you hear these claims that chimpanzees have culture. It's like, well, no, they don't, not really. And the reason for that, it's easy to figure out that they don't have culture. I mean, let's say chimps have been around, roughly speaking, for 15 million years, which is not a bad estimate because we diverged from them about 7 million years ago, and the evidence is pretty clear that the thing that we diverged from looked a lot more like a chimp than it looked like us. So like we've been booting it ahead madly, developing like mad, and the chimps have been laying back and eating leaves. You know, so do they have a culture? Well, they've had 15 million years. You know, they haven't even built a hut yet. And the reason I'm telling you that is because if you're a culture-generated creature, and you only manage, say, one discovery every 100 years between all of you, if you have 15 million years to get your act together, that's a lot of 100-year segments. And so even if the chimpanzee was building culture at the rate of 0.0001% a year, if you compound that over 15 million years, you have the Empire State Building. And there aren't Empire State Buildings that chimpanzees are living in, and so therefore they don't have culture. Now, they might be able to recognize their peers in the dominance hierarchy. They can do that. And they can use, maybe they can use simple tools. But the tools they use seem to be dependent on the environment that they inhabit. You know, because some people say, well, some chimps use one tool and some chimps use another. But, you know, if you're going to live in a rocky place, then you might use rocks. And if you're going to live in a place that has sticks, you might use sticks. But that's not because you're different. It's because the environment's different. So, anyways, chimps can't imitate one another very much. But humans, man, we're ridiculous. Like, we're so imitative, it's absolutely crazy. You know, and that's so cool because what it means is that once you get a pattern of behavior, you whip up a new pattern of behavior, I can watch you and I can just instantiate it in my own body, you know, maybe a bit awkwardly to begin with, although maybe sometimes better than you can, and bang, I've got that. And so we're always looking around at each other, seeing what we're up to, and as soon as we see someone who's up to something interesting, then we can do the same thing. Children do that because they imitate, right? But they're even better at it, man. They generalize across instances of imitation. So for example, remember when you're a kid, and you're playing, maybe you're playing house, and you're the mom, or maybe you're, I don't know, maybe you're the house cat, because children will certainly do that. And so let's say the child is being the house cat, so he or she is down on, you know, all fours, zooming around like a cat, maybe meowing and, you know, rubbing up against their mother's leg and looking for a milk in the bowl. And they're not exactly imitating their cat. Because if they were exactly imitating their cat, they would be moving exactly the same way the cat moved. But no, they're not. What they're doing is they've observed the cat across a wide variety of environments. They've abstracted what constitutes generalized cat behavior from all of those instances, and then they can instantiate the spirit of the cat, which is sort of the movements that make up catness. And then you, because you're so smart, you can watch them zooming around on the ground, and despite the fact that they don't have a tail or ears or fur, you're going to figure out pretty quick that that is now a cat. And children do the same thing with their parents. Like if they're playing house and they imitate their father, you know, they may, to some degree, try to imitate the sound of his voice, and maybe even use a couple of his favorite phrases. But basically what they're doing is trying to act like a father rather than imitating their father. So it's like, it's meta-imitation, right? So I watch you, I watch you, I watch you, I watch you. There's commonalities across all those instances. I extract the commonalities, I embody it, and then when I play, that's what I'm doing. I'm figuring out how to embody the commonalities across multiple exposures. And you're doing that when you're like 3. You're so smart. And then even if you're asleep, you're doing it, because you're doing it in your dreams. And so human beings do that, no other animals do. So when you're thinking about the ways that we're weird, you want to put imitation way up there on the list, because you can, you know, think about deaf people, like congenitally deaf people. They don't have much access to language. You know, say they don't learn sign language, because that used to happen in the past. It's like they can still wander around in the world and fit in. Well, why? Well, because they're so good at imitating, you know. They get all the nonverbal stuff, and that's a lot. So language is, you know, great and all that. Language actually enables you to imitate across space and time. That's what it's for. Because, you know, maybe you whip up a new action, and then you write it down in words, and then you send it to someone, and those are instructions, by the way, because that's what instructions are. You send that to someone, and then they read your code for behavior, and then they act it out. And so language enables you to move imitation across space and time. And that's a really good way of conceptualizing language, because it's a Piagetian way, because sometimes we might think that language is there to describe the world, you know, in a scientific sense. George Kelly kind of thinks that human beings are sort of like natural scientists. But natural scientists are much more concerned with what is than with how to act. So Kelly's wrong. What human beings are more like is natural engineers. Because we're always, you know, zooming around trying to figure out how to fiddle with things, much more than what they are. And as I mentioned to you earlier, a pragmatist would say, well, it's an artificial distinction because things are what they are when you fiddle with them. That's in fact what they are. So that's pretty smart.